Good morning. My name is David Gregory. I'm the China Market Business Advisor, specializing in the advanced manufacturing and transport sector for the China-Britain Business Council. And I am delighted to welcome you all to join the first CBBC Automotive Webinar of the new year, organized in collaboration with and with the support from the University of Birmingham. I'd also like to mention Gazgu, our media partner, who are supporting us with live streaming this event to their clients in China. Gazgu is the world-leading automotive industry information service platform, providing various professional information services for the upstream and downstream of the automotive industry. The China-Britain Business Council supports UK companies to succeed in doing business with China, whether that be exporting goods, technology, expertise, perhaps operating within China or working together with Chinese companies in some way. And we do this by offering a range of practical services tailored to a company's specific needs. But in a wider sense, the industries that we focus on reflect what is important to bilateral trade and also our members' focus. Therefore, our interest in advanced manufacturing and specifically the automotive sector within that. And the reason being, for example, very simply that with exports from the UK, just one example in Q3 last year, vehicle exports from the UK to China topped something in excess of £1 billion. But it's not just about pure exports to China. We're going to hear from several speakers this morning and understand how China and the UK are working together and across borders to push forward with the development of new technologies. As well as the work we do with individual members and companies, we strive to deliver a program of newsletters and webinars, face-to-face events, we hope again in time, to share information and exchange ideas on topical issues that are of interest to all of us involved in the auto sector and in business with China. Agenda slide, please, Chris. The theme of this particular webinar concerns the use of new materials within the automotive industry. And we have some great speakers lined up this morning, as you can see from this agenda. We have 5 speakers in all. I will introduce each one as we move through the program. And at the end of the speaker sessions, we'll have a Q&A spot with the speakers forming the panel, I think with the exception of perhaps Professor John Frampton, who has other commitments, unfortunately. If you wish to put a question to the panel at large or a particular speaker, then please type your question at any point during this session into the Q&A box on your screen, and we'll address as many as we can when we get to that point. So it's my pleasure to introduce our opening speaker, Professor John Frampton, who is the director of the China Institute, also the Deputy Pro-Vice Chancellor for China at the University of Birmingham. And John is going to share with us something of the engagement that the university has with China, and in particular, the role that the China Institute plays. So over to you, Professor.
Okay, well, thank you very much, David. Good morning, good afternoon, good evening, wherever you may be around the world. So it's a great pleasure for me as the director of the University of Birmingham China Institute to say a few words at the beginning of this webinar on advanced technologies in the automotive industry, focusing on the application of new materials, which has been organized, as David said, between the University of Birmingham and the China-British Business Council. My role and that of the China Institute at the university is to encourage and facilitate engagement of my Birmingham colleagues with opportunities in China, paying particular attention to the development of long-lasting partnerships. I'm very much helped in this role, it's not just down to me, of course, by my academic colleagues who are actually the ones who have the engagements and do the work, and by a support team both here in Edgbaston and in our China office in Guangzhou, which has been in operation now for well over a decade. So our engagements, University of Birmingham's engagements across and with China are extensive, with universities and industries in both research and education. And we cover a very broad range of disciplines, as is represented by the University of Birmingham. And these range from perhaps familiar topics for this audience today, so transport, energy, and manufacturing, to subjects such as paleontology, the environment, healthcare, and even Shakespeare. So pretty diverse, really. In the area of advanced vehicle technologies, my Birmingham colleagues already have many extensive collaborations with both Chinese academics and the Chinese automotive industry, focusing on topics such as hybrid engine design and the application of data science and artificial intelligence. As in many fields of technology development, an imperative looking forwards is carbon neutrality. And Birmingham is striving to work with Chinese partners in particular in this direction. And it's perhaps timely that the University of Birmingham and Southeast University in Nanjing recently launched what's called the World Alliance of Universities on Carbon Neutrality, which engages many top-tier universities in China, in the UK, and around the rest of the world. And this launch was set to coincide appropriately with the opening of the COP26 conference in Glasgow at the end of 2021. Our approach to advanced technology development, like many areas of our research, is multidisciplinary and tightly linked with the ambitions for sustainability and environmental protection, covering not only engine design, but also subjects such as emissions control, battery recycling, and sustainable business plans. So I hope your webinar, the discussions, the talks you're going to hear and the discussions afterwards and the Q&A, I hope this is a great success, and that through this event and other discussions with Chinese partners, the university can have a significant impact in shaping an economically strong, sustainable, and clean future. Thank you.
Thank you very much indeed, Professor Frampton, for that introduction on behalf of the university. And it's very interesting to hear, you know, that, shall we say, the already what is a very long relationship with China. When you talk about your Guangzhou office being operational there for 10 years already, and you talk about the sectors that you're involved in: transport, energy, manufacturing, environment, healthcare. I mean, I know some of these are beyond AMT, but very, very relevant to the development that the UK and China are embarking on together. So it's very interesting, and thank you for that. So let me now come to introduce our next speaker, Professor Hongwing Xu, who is the head of Vehicle and the Engine Research Centre at the University of Birmingham. He's going to talk to us this morning about the aspect of the university's research into the UK and China automotive field. Professor Xu gained his Bachelor of Engineering and Masters of Engineering degrees from Hefei University of Technology back in 82 and 84 respectively, and then received his PhD from Imperial College in 95. He was a technical specialist at Jaguar Land Rover prior to joining the University of Birmingham in 2005 and became a professor in 2009. Amongst his many other activities, he is also president of the UK Chinese Society of Automotive Engineers and vice president of the Association of British Chinese Professors. And I'd also like to add that Professor Xu has been instrumental in working with me and CBBC to organize today's event, and is a great force for encouraging and facilitating Chinese and UK companies working together on common goals. So, Professor Xu, over to you.
Thank you, David. Can you see the screen? Slides?
Fine.
Good, thank you. Hi, everyone. It's my pleasure to be here, and many thanks to CBBC for organizing this webinar. And today we are here to exchange some of the information about our work at University of Birmingham in the field of automotive and in connection to China and UK industry. Now my talk is quite brief with a short introduction of the background and our work and current project from our colleagues and myself, and end with a short summary. As Professor John Prominence just mentioned, that the automotive research is very active at the University of Birmingham for over half decades or longer than that, since 1960s. Now we have 40 relevant related subjects, and with 20 to 30 plus of our pillars of principal investigators working in the area. We have a center named Case Automotive Research and Education Center. The areas cover autonomy and sensing, and business and strategy, impact on the environment, and sustainability, and circular economy. So clearly, within a short time, we are unable to show all the expertise from our colleagues. Here are some examples of large research groups in the sensing, energy storage, and fuel cells technology, and of course, energy storage and for vehicle technology research, and where we are have a large group of people working on powertrains. So where I'm sitting in the group of the center working on projects in collaboration with China, and this is one example of the active National Science Foundations Council's project with China for 5 years, in collaboration with Cambridge University as well, and Beijing University in China. So the research is to research the evolutions of emissions from vehicles from start of the formation of the emissions, and also the impact onto the human beings and onto the environment as well. And the research includes work in collaboration with Share on injected deposits, which is a significant impact on the performance of the engine, especially for direct injection engines. And we have been working with colleagues in Beijing University and Tsinghua University, and colleagues at Birmingham, using experimental and modeling techniques to study the particulate emissions for direct injection engines. And this research are now extended to vehicles using electrical or electrified powertrains. The talk made by my colleague, Professor Roy Harrison, is one of the examples to show the work at Birmingham in collaboration with China. And Professor Harrison is one of the lead scientists in this country working on vehicle emissions. So that is now being extended to the automotive research. And again, in collaboration with China, here is one example to show the project with the Suzhou Automotive Institute to work on electrified powertrain and vehicles, to study the energy management and also the efficiency of the engine and the powertrains, to use artificial intelligence for the control of the powertrains, and to show the powertrain or the vehicle efficiency continuously growing in the designing and testing and also maintaining on a road. And that is the future technology for vehicle control. And with BYD, which is one of the largest automotive manufacturers in China, especially the world leading on new energy powertrains on electrified vehicles, where we study the high performance and combustion engines and also the electrified powertrain system to achieve very high efficiency. Now the engine for the hybrid reached 43%, is one of the best in the world. Now with hybrid and also the conventional combustion engines, for many years we will see the engines will be used for hybrid. So the engine performance need to be further improved, efficiency need to be increased. In this project, we have developed autonomous artificial intelligence-based engine calibration methods using our own software for the calibration on a production direct injection engine. Then the work continues for hybrid and electrified vehicles and electrical cars. In the future, we will see that the engine-based testing facility will be combined with electrified powertrains and the information on the road, and using the virtual testing environment, we're using the big data and using driving simulation. Now we can study our vehicle's performance in our laboratory using both hardware in the loop and modeling techniques using artificial intelligence for future control of the powertrain and the vehicle operation on the road. So that's a very short highlight of our current work with China. And now we are moving to the new modern, so-called full modernization of the vehicles, which is called connection, automation, sharing, and electrification. There's a lot of work. Now we will work with more and more collaboration with Chinese colleagues, and we hope we develop further technology, advanced technology for our future vehicles. So many thanks to all supply of support to our work. So without the support, this research cannot reach our goal for industry application and the benefit to the society, to the public. So that is all from me, and thank you for your attention. Okay.
Thank you very much, Professor Xu, for that. It's very interesting to see the range of topics and, shall we say, different specialities that you're tackling within your research and development there. And I've got a couple of questions that maybe I'll, if I have the opportunity, I'll put to you myself when we get to the Q&A session. So now, it's my pleasure to introduce everybody to Dr. Li. Dr. Li is the Deputy Director for the Commercial Vehicle Institute for Geely. He's very kindly giving up part of his evening to talk to us because he's based out in Hangzhou, I think, as I remember. Dr. Li obtained his Bachelor of Engineering degree from Xi'an Jiaotong University, and then his Master's degree from Tsinghua University, and ultimately his PhD from Queen Mary University, London. He worked previously as the Director of the Automotive Engineering Institute with Shaanxi Automobile Group, and then Chief Engineer of Shanghai Group, respectively, prior to joining the Geely Group. He's got extensive experience in the field with over 20 years in the automotive industry. And Dr. Lee is going to talk to us this morning about the application of light materials in commercial vehicles, which I think is going to be very interesting because the majority of the focus tends to be on passenger vehicles all the time. So I'll be very interested to hear what you've got to share with us this morning. So over to you, Dr. Lee.
Hello, good morning, good afternoon, or good evening to all of you. So I'm Hong Yan Lee from Geely Holding Group. So today my topic is about the light materials in Geely commercial vehicles. And I give you some application cases, especially on the lightweight technology area. So you may know Geely Holding Group very well. And right now, you could see lots of very famous brands on this screen, like Volvo, like Lotus, also Smart, Proton. And right now, I'm from Geely Commercial Vehicles Group, which is a subgroup of Geely Holding Group. And you can see the shared shape logo, which is the brand of Geely commercial vehicles. Its brand name is Farizon. That's where I'm working for. So as the previous experts mentioned, like carbon neutrality, and this kind of policies is implemented in all of the world. So not mentioned in China. So regarding the carbon dioxide emission, especially for the commercial vehicles. So in China, there's only about 11% of the overall vehicles, which is about the commercial vehicles. But those commercial vehicles just has about 50% of the overall carbon dioxide emission. And right now, the Chinese government is implementing a frog leap forward policy on new energy vehicles, especially on new energy commercial vehicles. In order to achieve carbon neutrality, one of the most important technology, which is about lightweighting technology that can be applied in the vehicles to achieve the final carbon neutrality output. There are lots of benefits of commercial vehicle lightweighting. For example, we could save energy and reduce carbon dioxide emission. We can improve vehicle safety and comfort performance. We can improve the pure electrical range and the payload. In the end, the customer could gain more profit. So what's about lightweight technology refers to the use of modern design methods and effective means to optimize the design of automotive products, or the use of new materials to ensure the overall performance of the vehicle on the premise of reducing the weight of automotive products as much as possible in order to achieve weight reduction, energy saving, emission reduction, safety, comprehensive indicators. So I will give you an example, which is about the lightweight technology implemented in body in white. And you may know it very well. Body in white, which is the foundation of safety durability, NVH, and vehicle handling is an important window to measure the technical level of automobile OEMs. So the next stage, I will give you some lightweight design technology implemented in Geely's commercial vehicles. And our philosophy by implementing lightweight technology in those commercial vehicles is based on two pillars. One is about the performance-driven material design, which is especially about the safety. And the second one is about the fuel economy-driven design. Also, we just use the new materials and the new manufacturing process in order to achieve a bigger fuel saving. So by implementing the lightweight technology in those vehicles, we do our jobs in three major areas. The first one is about implementing new materials like the advanced high strength steel, lightweight alloys like aluminum alloys, as well as composites. The second area is about structure. Like we could use a topology technology to do our modular design, structure optimization. And third area is about the manufacturing process, like connection, hot roll pressing, as well as precising casting, and so on. Also, we achieve our goals through three different stages. Stage one, we promote the successful lightweight solutions of a 2.0 platform. We newly developed platform, realize platform-based application, and know the cost of lightweight. And stage two, three, material upgrading, product structure optimization, introduction of new technology, achieve continuous weight reduction of the vehicle. Also, we do some prospective study, explore the future light duty truck information, intelligent new technology in vehicle lightweight application. And this is the one example, which is about the BIW, body in white. We just adopting some new lightweight technologies. So the first stage, we just do the preliminary study of lightweight solution. And then we do structure topology optimization. Then we study the material and dimension, or also do north-south optimization on the structure, and as well as manufacturing engineering feasibility studies. Then we do the performance verification of the overall BIW to see whether we could achieve our weight reduction goal, as well as keep the performance level of the BIW. Here is one example by using the new materials into the BIW. So you could see the red area of the structure of BIW, which is about the advanced high-strength steel we used. Previously, we used the long of the AHSL material, but for this new BIW, we increase the AHSS material from 0 to more than 22%. But the performance is not reduced, it's significantly improved while maintaining low cost And I will give you the example. I will give you the results. Also, we do lots of structure optimization, and we achieve the BIW stiffness increases, the passive safety performance increase, and overall BIW weight is reduced. And we can use a lightweight index to measure the level of weight reduction and the performance improvement. So from this slide, you can see we can achieve a lower lightweight index from the old model to the new model. Also, the passive safety performance is significantly improved by doing those lightweight technology study and implementation. And this is the test picture. Also, not only about the BIW, but also the suspension system. For example, for the leaf springs suspension system we used for a light duty truck. So we use a steel plus composites compilation for a suspension system. So we could achieve a weight reduction up to 42%. And furthermore, we designed a glass fiber composite suspension system. So we achieve more than 55% weight reduction, which is a big result of weight reduction for that system. Also, for the powertrain driving system, we newly designed electric drive axle from the previous driving axle system. So we achieved an overall fuel economy 5% increase, and the powertrain system, the weight is reduced up to 60 kilogram, but also the overall cost of the system is nearly the same. So by using all these kind of newly developed materials technology, as well as like powertrain new design technology, we achieved up to 200 kilograms weight reduction for a newly developed light duty truck, but also keep the cost at the same level. That's just a very brief introduction on what we have done on this lightweight reduction area. So finally, New Year is coming. So I wish all of you happy life. Guinea Drive. Thank you.
Thank you very much for that very interesting overview of how you're approaching this whole challenge of reducing the carbon emissions in commercial vehicles. Dr. Lindsay made a few points there that we might come back to in the Q&A session. So now it is my pleasure to introduce our next speaker, who is Marcus Henry, the Lightweighting Research Manager for Jaguar Land Rover. Marcus is a chartered engineer with over 25 years experience of engineering, not just in automotive, but also in the aerospace industry. And his job roles have spanned the complete life cycle of products, from research, product development, prototyping, testing, mass manufacture, and warranty. And Marcus is going to talk to us this morning about Project Tucana and its alignment with JLR's Reimagined strategy, which sounds a very interesting title, Marcus. So we're interested to hear more about that. So over to you.
Thanks, David. Let me just share my screen. David, if you could just let me know if you can see my screen.
I can.
Well, thank you. And some of what I'm going to talk about backs into what Dr. Lee has just said, but coming at it from a slightly different direction, talking a little about time frame and then a bigger why of what we're trying to do. So, I'm conscious the title of this event is the use of new materials within the automotive industry, and I'll focus on that. I've only got 3 slides to show you, but I think it's quite good to make sure we're all based on the same page of innovation timeframe. And this relates to hardware delivery at Jaguar Land Rover. Software's got a different time frame, but ultimately, why are we innovating? It's about converting science into wealth. That's why we go to work. That's why we get paid. We convert science to wealth. So along the top, you see different time frames of academia, collaboration, and industry. This is a maturing scale. I know it's a technology readiness level, and I think it's a fantastic way to describe the maturity of technologies. Alongside the technology readiness level, which we need for new materials, we would have a manufacturing readiness level that says its counterpart of how scalable is the production technology to go hand in hand. But in my role, I focus as a lightweight research manager. That's my job, and it's to bring disruptive technologies to market. When I say to market, on the very right-hand side, that's on the market. It's in a showroom, you can buy it. And I generally divide that into 2 phases. Once we get to the industrial, the TRL7, that's about delivery. You're delivering your technology. You know what to do. There's no place for error. We have to have all the processes correct, the supply chain correct to avoid issues. It gets very emotional if you're at that maturity level and you get issues. Now, I also cover in my role about TRL1 to TRL7. If we just start at the left, TRL1, 2, and 3, I would know that as academia. That's PhD research, fundamental science research. And that's sort of pushing the forefront of humanities knowledge. And really, it's about setting a direction and monitoring, because we need to react to new learning. You know, things change, things are learned. We may change course, may change direction. Then into the collaborative phase, the maturity of the materials or the product, bringing it through different technology development and prototyping. So I just thought I'd give you an introduction into that slide, which the message I want you to take away is new technology takes a long time to get in to the showroom of a vehicle. You can see along the bottom, you know, a new idea for academia today could take 11 years to be in a showroom. And that 11 years assumes that the research learning aligns perfectly with the industrialization, the next vehicle to come along, etc. So I just thought I'd give you a little introduction to that type of time frame. But what we also need to, our measurables as we go through this very much are the readiness of technology, as you see on the screen, the readiness for manufacturing, costs, and more importantly, recently, nearly a dominant factor that's come in is the carbon impact, the kilo CO2 equivalent. So I'll come on to that in a second, but that's the time frame. It takes time to get new technology to market. If I now give you an introduction to a project I've led for the last 4 years. This is called Tucana, and you can search it on the internet to find out a little bit more. But the intent of it is affordable structural composites made in the UK. And if we think about electrification, that is JLR's future, and I'll show you more in a second about putting a timeline to that. But Jaguar Land Rover sells a lot of what I know as 4x4 vehicles, or open back structure vehicles, where the rear seats can be laid flat. That means, you know, we've got, if you take a cross section and go at the back wheels, we need a structure there that's stiff, because electric powertrains, you know, generation 1 battery electric vehicle nearly produces the energy output of 100 years of combustion engine development. And that's Gen 1. When we think ahead to other generations I'm aware are coming, we need to have a step change in body structures to react that huge energy input. And what we have done is investigate composites, new materials composites, with the idea of bringing to automotive what aerospace know, what yachts know, what high-end sports goods know. And we need to demonstrate that in an existing environment, which is always tricky, because we're trying to put composites and make the maximum use of those into a current vehicle structure. So we've slightly compromised at the true art of composites. And when I say composites, on the screen you can see reference to carbon fiber and glass fiber. But the project's been really a huge success of taking approximately 60 metallic components away in the rear end of the vehicle and replacing them with 18 components being carbon or glass. So huge component reduction. And just to put a few metrics on it, we're taking nearly 70 kilos of steel, or 70 kilos of aluminium, sorry, away, and replacing it with 10 kilos of directional carbon fiber. And that takes the loads. As we saw, Dr. Lee showed us some schematics of topological engineering. It's that magnitude of difference. So using high performing materials. Part of the difficulty we have with that is predicting it. As an engineer, the technology readiness level means I need to have correlated computer-aided engineering models to make sure we can launch the project. And a composite data card has got about 27 fields in it versus 3 fields for a metallic. And that rigor of populating those fields and making sure you've got them right can take 2 years per material. And so it's time consuming, and that's a journey I've been on for 4 years. And we've been supported in the UK by Innovate UK via the Advanced Propulsion Centre to take this project from roughly TRL 5 to TRL 7. Yeah, we've also tried to have minimum disruption on our manufacturing assembly plants. In other words, it goes through a standard paint process. And that's caused issues in the resin system of the composite, making sure it's capable of going through those temperatures without degradation or blistering. So we've had that challenge, and we're trying to pitch this at roughly 50,000 units per annum as a volume point. So ultimately, what have we achieved? a vehicle stiffness up by 30%, and that's significant, while also having a weight saving of 35 kilos, which will lead to a colossal CO2 reduction. But why, again, why have we done this project? It's about JLR's sustainability journey. We call it Reimagine, and it's a journey to net zero carbon emissions. And we're transitioning by fast electrification across all models. You can see a schematic of Land Rover on the top and Jaguar on the bottom, with zero tailpipe emissions by 2036 and net carbon zero by 2039. Now, not many people that I've met understand what net carbon zero means, let alone how you measure it. For full measurement from ore or mining through to end of life, you know, how will the legislation work? Will this be taxed? There's so many questions, but what we need to do in Jaguar Land Rover, and we have done, is disruptive new technologies that help bring us along that journey. And that journey, as you see, by a timeline of 2039, only 17 years. And if we refer back to my first of 3 slides, new technologies, you know, can take 11 years to get into a showroom. So if an average vehicle life is 8 years, technologies we start today will impact that net zero in 2039. And that's my message really to you. The new materials, we are exploring them. They have to be done with such rigor, but a new metric that is emerging is about kilo CO2 equivalent to enable us to get to net carbon zero emissions. And we've made great strides in that journey through the use of advanced materials through Project Tucana. And I'm very happy to answer any questions in an upcoming slot. But I just thought that's a little introduction for you. Thank you.
Thanks, Marcus. Look, I thought that was a really interesting. I mean, you've used 3 slides and given a really great picture there of all the different complex issues that come into play. You know, as you say, the idea is starting at academia, and it's a long journey, very long journey to get from there to the showroom. And I think that's quite an interesting point that I hope we come back to in the Q&As of, you know, given the deadline set by the government and set, for example, by JLR themselves, it's almost mission impossible, you would say, but we'll get into that.
We need to, and this is why it's important to work together. Sure. If it takes us 2 years to prove a new material, why are we doing it in isolation? Right. But as you say, Q&A session.
We'll come to it in the Q&A, but thanks for that, Marcus. That was great.
Pleasure.
So now we're actually running a little bit ahead of schedule, but it's my pleasure to introduce our final speaker this morning, who's Dr. Jun Qiao, who is the Chief Engineer for the Chang'an UK Research and Development Centre. Now, we have had the pleasure of Dr. Jun Qiao speaking for us in the past, and we're delighted to welcome you back again. He's responsible for Chang'an's UK's powertrain strategy planning and advanced technology. He received his PhD from Loughborough University in 1990. He's also an honorary reader at the University of Birmingham and has some 29 years experience in automotive research and development. Immediately before joining Chang'an in 2013, he was the Transport Strategy Manager at the Energy Technologies Institute, which was a partnership between the UK government and 6 global energy-related industrial giants. And this morning, he's going to talk to us about Chang'an's interest in new materials. So, Jun Qiao, over to yourself.
Thank you, David, for the introduction. Let me just share my screen. Can you see it now?
Yes, we can see that.
Okay. Okay, good morning, everyone. Oh, good afternoon and good evening, wherever you are. Thank you for the opportunity to talk about this exciting subject of applying new materials in the automotive transformation towards sustained mobility. Now, this is a fairly mouthful, so I'll try to talk about it within about 15 minutes in 4 parts. So the first part quickly talk about this bigger picture, this whole automotive transformation towards sustained mobility, and then briefly about what that means for application of new materials, and then briefly about my own company's practice towards this, and then summarize. So, clearly is around the world right now, the hottest topic is about climate change, particularly since COP26. And automotive is part of this big picture. So we have to evolve. Well, it's pretty much, you either evolve or pretty much survive the fittest. As the previous speaker, Marcus already mentioned, my previous employer, Jaguar Land Rover, clearly goes through as far as it can go towards electrification. So I think the rest of automotive players, but I think the main driving force is actually the government. So the government try to kind of provide the driving force for automotive, transform towards sustained mobility through 3 means. One is the kind of, if you like, the stick is a legislation. So we used to, in the car industry, we used to the Euro 4, Euro 5, Euro 6, the emission legislation, the US, California, zero emission legislation, the CULEF. So those traditionally be focused on the pollutant emissions, but increasingly important are the CO2 greenhouse legislations. So the early years primarily been looking after the kind of CO2 emission per 100 kilometer or per kilometer or liters per 100 kilometer. Although in Europe, recently, European Union has announced the Fit for 55 is pretty much go even more drastic than that. It's already set a deadline for banning internal combustion engine by 2035. Now, it's not becoming a law yet, so it's a proposal, but we'll be keenly watching this space. So once it becomes legislation, then everyone just simply have to do it. While the government kind of, driving this through sticks, they also provide the carrots, things like allowance. So in the UK, if you buy an electric car, you used to be able to get £5,000 as allowance, although that allowance is reducing to £3,000. I understand that would be reduced further to £2,500. And the other third aspect is through policies. Now, policies somehow more flexible than legislations, because legislation is red line. You either meet it, or you're not allowed to operate in this business. Well, policy is more of a kind of thing like tradable. I give you example in China. Say China right now, every car manufacturer got to meet the 5 liter per 100 kilometer sort of fuel economy legislation, but they provide additional policies called a double point system. What it means is if your corporate fuel consumption is high, you get the negative fuel economy points. But if you provide electric cars, plug-in hybrid cars, or fuel cell electric vehicles, you actually gain a new energy point. So your new energy point can be used to compensate it for your like battlefield calling points. You can also sell your new energy point to other manufacturers. Okay, so that's briefly about why the automotive been going towards the sustainability and what's the driving force. So the second aspect, we'll talk about the new material, how that play in this new transformation. Now, this just briefly look at today, you know, our still about over 90% of our vehicles are produced and sort of powered by internal combustion engines. And the material, you know, traditionally we use, you know, steel body, although more and more manufacturers like Jaguar Land Rover, like Geely, start to look at, even ourselves, look at aluminiums, kind of even investigate the carbon composite, although carbon composite is still very expensive. Into the powertrain, you know, on the right-hand side, you can see is a lot of metals make various part of internal combustion engines and the mechanical transmissions. So clearly, that's kind of using material are abundant and cheap. The only exception I would like to emphasize is actually the pollutant emission treatment device called after treatment, particularly exhaust catalyst. That aspect we just can't get away with the cheap material. We have to use the precious metals, the platinum, palladium, and rhodium. So those materials are expensive, but we try to use it as little as possible. Okay, so that's a kind of today's picture. So if we go towards a kind of longer term, post 2025, 2030, clearly everyone's predicting more and more electrified vehicles. By electrified vehicles, now the first thing you need is basically batteries. So the battery is the so-called new oil. You know, it's increasingly becoming important, and the material used to produce batteries get more and more attention. You know, today, if you look at primarily the battery material Tesla use, those are the kind of nickel, cobalt, the aluminum ones, and those mainly for the battery cathode. You can also use others like lithium, cobalt, manganese, or other things more exotic, but it's more research stage like lithium sulfur, or even much longer term look at lithium air. But today is very much just kind of lithium metal oxides. For the anode, we still use graphite. But for collectors, we use a lot of aluminum and copper. So all those things are also in play. The next generation batteries, so-called the solid state batteries, basically using solid state to replace the electrolyte, the sort of liquid forms, and those also have a lot of new material people been looking at. So that just briefly look at the battery side of material application. And the second thing we go towards electrification, increasingly the electric motor replacing internal combustion engines. Now, electric motor, you also come in all sorts of size, shape, and types, but by far the majority type is still the permanent magnet machines. The permanent magnet is actually made primarily from the rare earth. They are a group of 17 elements here. I tried not to pronounce all of them, but they all got quite exotic names. Clearly, the kind of the biggest one to use element to use for permanent magnet is neodymium. As you can see, the price already increased kind of over 2.5 times. So it's clearly shows more and more need as we go towards electrification. And apart from magnets, you also need metal housing, copper sort of status. You got iron status. So you still use some traditional materials, but by far the biggest application right now is rare earths, and particularly things like neodymium. And the other one I'd like to mention, although it's not in the kind of a wide application yet, but the car industry has been researching this for many years. Fuel cell vehicles. Fuel cell vehicles is actually fuel cell electric vehicles. So fundamentally, it's electric vehicles. So you also got the electric motors, and but it also got hydrogen fuel cell and the hydrogen storage tanks. So hydrogen storage tanks need kind of carbon composite material. They're lightweight. Also, they're very durable, very tough. So they actually can withstand very high pressure. Today it's quite common we see this hydrogen storage tank that withstand this 720 bars. So it's kind of a quite exotic material to hold those hydrogen. And in terms of fuel cell itself, there's no secret that fuel cell itself use precious metal, primarily platinum, to be the catalyst for the hydrogen oxygen reaction. Although it use other things for membrane, for kind of for the plates, and so they're all kind of a sort of new material looking at. Even simple thing like air compressors, is not the standard air sort of compressor you can buy, because those actually have very little tolerance to lubricant. So we had to look at things kind of again, try to compress air without kind of traditional lubricant in there. So we had to look at a new way of doing things. So that's just to give you a sort of big picture overview. And I will briefly look at my own company's practice. Now, Chang'an, probably in the West, not many people heard of us. Well, I used to joke about this is the largest car company you never heard of. But in fact, we're actually a very old company. We are actually older than Ford. The company is established, it was established in 1864. So if you like, we are going to celebrate the 160 years of the long history of the company. Although in terms of making cars, we only started really in 1984. And if, Marx mentioned that car industry, typically the product development is very long. If you use 80 years of product cycle, that give us less than 5 generation vehicles. But we have been fairly successful. In fact, the January to September last year, we already making and selling over 1.7 million vehicles. And last year in total, we sold more than 2 million vehicles, including some sort of best sellers in its own sectors, things like a smaller SUV, we call it CS35, and there's a kind of larger SUV, we call it the CS75. So those vehicles actually is selling very well. Funny enough, exactly, we can't supply them enough. part reason is because we can't have enough computer chips, are not actually limited by, you know, sort of that bottleneck right now affects the whole car industry, not just ourselves. And going forward, the bad news is we're going to need more of those computer chips. And we also produce quite nice looking electric cars. And this picture shows the latest one we're going to launch called the C385. You know, it's pretty nice looking electric cars. Also, we are looking at you know, fairly efficient materials so that this car can drive over 600 kilometers in one charge, and you know, it's not going to be very expensive because one of the problems of early electric cars, you know, when they become very expensive, it's certainly not affordable. So we had to make affordable electric vehicles that can sell large quantities. So that's our parent company. Although the parent company actually we established 4 overseas engineering centers. One in Italy, Turin, is focused on styling. One in Japan focused on vehicle interior. One in America focused on chassis. And the one I work in is right at Birmingham Business Park. It's called the China UK R&D Center. We were established about 11 years ago, primarily focused on powertrain. So we started designing new generation engine and transmissions for the company. They actually selling very well. I think the engine transmission we produced already sold over 600,000 units, we were told. And just like everyone else, we are going through this transformation. So we move away from kind of traditional internal combustion vehicles towards electrified vehicles. And we're very busy, you know, investing in research. And I just give you 2 examples of 2 research projects my team been working on with the UK partners, partly funded by UK government. The first one we did was a project called the Impact. We did with a partner called the Magnumatics. So primarily we're looking at new way of designing motors. We are looking at electric motor fulfill 2 functions, as well as the driving vehicles. We also use a so-called magnetic gear concept. So almost use the electric motors as a kind of, you know, performing gearbox functions. So we have to look at some new material in there too. And the second project I like to talk briefly is the sort of fuel cell vehicles. We partnered with a company called the Intelligent Energy in Loughborough. So we look at a new way of doing fuel cell, not to get rid of humidifier. So look at more package sort of efficient, higher power density technology. You know, intelligent energy right now, you will look at the fuels that apply to aero industry. So we actually benefit from those kind of you know, technology breakthrough from the air industry down to the automotives. And we also look at the new way of controlling it. So we also recently introduced a new partner called Lyra to look at the new DC-DCs handling, you know, high power, high voltage, look at the silicon carbide material rather than traditional silicon materials. So there's a you know, through this transformation, we found you know, lots of new opportunities, and you know, we actually very excited about this, you know, this opportunity of going towards electrification, that sort of space is open up for new research. So I just briefly talk about the first 3 parts. Now let me summarize. So what we see is that the industry is clearly move away from internal combustion engine powered vehicle towards a new one, I call it the kind of small letter ICE. Now the I stand for intelligent vehicles, and the C is connected, and the E is clearly, well, I would say the bigger one is the environment friendly, but right now is primarily look at electrified vehicles, the electric cars, plug-in hybrid electric cars, and also fuel cell electric vehicles. So although the letter on the surface looks the same, but the content can completely different. So in fact, the car industry already gone through 4 generations of that. So from sort of generation 1 of pure mechanical device into a second one introduced some kind of electrical control, and the third one start to look at more hybrid one, part of a mechanical engine, part of it. So the electric machines drive vehicle now go towards the 4th generation sort of completely electric driven vehicles. So as I say, this journey it just started, so we're all very excited about it, and we're doing a lot of research towards it, and I have no doubt that the new materials really underpin all this, this transformation. Okay, thank you very much. I'd like to stop there, and looking forward to questions. Thank you.
Thank you very much, Dr. Drinchia. That was very, very interesting, and I have to congratulate you. You have brought us perfectly back to our scheduled timing. Well done. Thank you for that. So that brings us to the end of the, shall we say, the formal presentations by the speakers. We're now moving into the Q&A session, where you, the audience, have the opportunities to put questions either to the panel as a whole, or if you choose particular speakers. We already have a handful of questions in the Q&A box, but please do, you've still got the opportunity. If you want to ask a question, please write it in the Q&A box, and we will try to get to as many of them as we can. So let's just make a start on the questions we've got. And I'll start with what is a simple question, but maybe a complicated answer. This question is directed at you specifically, Marcus. And the question is, what is the effect of carbon fiber on the cost of the vehicle compared to traditional materials?
Significant increase, simply put. But the more you buy, the cheaper it gets. If I just give some rules of thumb, there's about 100,000 tons of carbon fiber produced every year, majority going to the wind turbine industry. Automotive takes very little of it, though if automotive moved, simple rule of thumb calculation, JLR alone would take half the global production of carbon fiber. And on that note, the more you buy, the cheaper it gets. Yeah. And when we talk about cost, it's nearly like unraveling layers of an onion, because cost, the piece price, will have an impact on the CO2 impact of the product, where it's made, the feedstock, the recyclability of it. But in essence, the people that use carbon fiber intensively at the moment do so because they understand the properties. Aerospace get it, they know it. High-end sports cars get it, they know it. Luxury sports goods get it. There's no escaping the fact today it'll cost more than what we know.
Just out of interest, Mark, and it's, I suppose it depends on exactly what you're making, but is the cost in the materials or actually the manufacture, the processing of it?
Again, layers of an onion. So simply put, the materials are energy intensive. Today, the most cost-efficient solutions come as byproducts of the oil industry, and then they're carbonized or burnt into fine strands. Then they're agglomerated into tows, And for example, automotive use 50,000 strands at once and make that into a tow and then use that as a feedstock. So when we scale that up, you know, traditional cars and even aerospace use fabrics, and fabrics are inherently wasteful because they've got nesting areas where we cookie cutter out shapes. So the manufacturing process can be wasteful, but again, the economics of volume come into play, and that's why through Tucana, we've pitched it at 50,000 units a year, which is more very automated and very production efficient, you know, a few minutes cycle time. Even aerospace maybe make 2-3 planes a week. You know, Jaguar Land Rover is a small company and we make 2,000 a day.
Right, okay. Does anybody else want to make a contribution on that subject, or has Marcus got it covered? No? Okay. We have another quite specific question in from a gentleman called Anthony Cash, Dr. Anthony Cash. I'll read it out in its entirety because it might make a bit more sense. Good morning. Thank you for the opportunity to engage. I'd like to ask about tri-party collaboration on the use of lightweight, fire-safe composite materials in the design and manufacture of buses, coaches, trams, and light railway vehicles. How would a UK company join your partners to ours? We represent a UK Tier 2, assisting a USA manufacturer of patented phenolic resin bus, tram, and train flooring. I don't know if you managed to catch all that, but it's a question from a Tier 2 supplier wondering how they would join forces with institutions and companies like yourselves. Is it simply a question of talking to you?
Who's that directed at? Sorry, David.
It's directed at everybody. It's directed at all the panel.
Let me start with JLR. So JLR's got a supply base innovation website that's going to go live very soon, which will gather suggestions as to how you can work collaboratively. But
Okay.
there is very much a need for that type of product, and I'm very aware of a number of investigations going on utilizing
But that would
such
be
phenolic resins.
that would be a question of getting in touch with you directly then. Yeah.
Correct. Try going through LinkedIn if you want to chat to me, for example.
Okay. Anybody else want to come in on that? Perhaps Professor Hongling?
Yeah, I would like to say that within the limited time for my talk, I didn't covered all the expertise in our university. We have a lot of work projects in relation to new materials, for example, lightweight materials you just speakers I mentioned talked about, and materials for batteries, working on chemistries, fuel cells, catalyst materials, for example. The website I showed in my presentation perhaps is the good source for people who may want to find out more about our work in the area of materials. The talk, the title you give to me was the work perhaps more about what is going on now in collaboration with China already, with the industry, etc. But there's potential there to work all of you with Chang'an, with their offshore and GCV.
Thank you. Anybody else want to add anything to that? Okay. We have another question. This question is from a gentleman called Douglas Gray. He actually put a couple of questions in here, but I'll focus on one. And Douglas was referring to, obviously what's been spoken about, weight reduction and other, shall we say, the mechanics of how cars are put together and how they are powered. But his question says, equally weighted, the way that we drive cars is changing, and the way that we control and interact brings together further potential for reduction. You know, how much attention is being paid to these areas? In other words, the way that we use cars in the future. That's the sort of, I'm opening that to anybody in the panel who's got an interest to answer that. And I guess, you know, Doug is, I guess, talking about, you know, the fact that you've got car sharing platforms, you've got all sorts of things where it's, you know, moving away from traditional ownership and usage.
You know, one of my colleagues is an expert at what I would know as HMI, human machine interface, and he looks a lot at the cognitive loading of the information delivered by the vehicle and how a user of the vehicle may process that. So there's a lot of work in that field. If I just start off the answer.
No, thanks for that. Well, Jun Xiao, if I can ask a question to you, perhaps, and there's with Chang'an with Chang'an sales of vehicles in China, is it still a very traditional? You're selling cars to one owner, or are there more interesting models of ownership or usage developing or being developed?
We look at the two ways. So while we still have a traditional way of selling individual owners, we also formed a alliance, joint venture with First Auto and Dongfeng. We call it the T3 kind of mobility. There, we pretty much are looking at new business models. We're looking at kind of shared mobility. People kind of, if you like, rent for use. And then there we also look at providing some electric vehicles for that purpose, because the more the vehicle get used, the quicker the kind of a payback time for those capital investments. So those are kind of early days for this, you know, new business model, but it's happening. It's happening at a sort of accelerated rate, but still not overtaking the traditional way of you know, selling individual customer yet.
Thank you for that. That's very interesting. Dr. Lee, are Geely doing anything interesting in this area?
Right now, yeah, we indeed do some maybe new business models in order to implement more and more like new energy vehicles in China as well as in the worldwide. For example, the cell for new energy vehicle is quite expensive. The individuals would not pay one time for it. So we promote like a rent for use policy.
Mm-hmm.
Also, we could provide for the commercial vehicles areas, we could provide like a cargo transportation services to big companies, like business companies. Rather than just, yeah.
Sorry, is that specifically about commercial vehicles, trucks and things?
Yeah,
or,
yeah. So rather than just sold out the individual vehicles to the end users, so we provide cargo transportation services and so on. So that's kind of also we could provide a series of services to the end customers. For example, we built and run the charging station for our end users. So those kind of infrastructure facilities we could provide within a whole package of services to the companies as well to the individual users of our vehicles. So right now, so the automakers is not like just design, produce, and sell vehicles, but also we are the service providers, indeed.
Thank you very much for that. I've got a question that I'll just throw in that occurred to me when Dr. John Chow referred to the different drivers behind, shall we say, progressing the development towards different energy vehicles. And you talked about allowances, and you indicated that allowances that consumers got for new passenger vehicles were being reduced. And there's been a bit of publicity over the last week of this in the UK. And it's interesting because when you, at the moment when people are getting, shall we say, these allowances on purchase, they're getting reductions on tax, there's almost seems to be a perception that people who buy electric vehicles in the UK are sort of getting a free deal somewhere along the line. But obviously this will have to change, because as we end up with the internal combustion engine vehicles being replaced, the system of gathering funds to pay for roads and other infrastructure have got to come from that source rather than the internal combustion engines. And it seems that people might find this a bit of an unpleasant shock. Do you think that this is just a matter of time for people to adjust to whatever system comes in, or do you think they're going to feel cheated in some way?
David, that's a really good question. In fact, my last job, we were looking at this whole bigger picture of wide adoption of electric vehicle, what that means. Clearly, the subsidy side, you can't go on forever. Right? You're absolutely right. There will be some pushbacks for that. There's also government taxation reduction, because you buy a little petrol diesel. In fact, a lot of them are taxed. It's not the fuel itself. So the billions, the government take from selling those fuels, and if you go towards electricity providing that, there's a lot of tax that government going to get. So there's a number of issues about paying charging stations, and so those things all been discussed and people working on them. Clearly, this transformation is not plain sailing. New problem will come, and one thing I would say is, I'm a human being, always have an ingenuity that when there's challenges, we will always find a new way of dealing with it. I'm always optimistic. You can tell.
Okay, thank you for that. Does anybody else have anything to add on that? How do they see this thing panning out in the eyes of the consumer, I guess, as it becomes obvious that it will be not necessarily a free deal to buy an electric vehicle anymore?
I think for the next 20 years or so, we will see the engines are going to be used worldwide in hybrid. But for sure, this electrification of vehicles have created opportunities for a lot of research and new areas, exploration and innovation. And I think the purpose of, for example, one of the purpose of today's webinar is to establish more connections between university, including Birmingham, of course, with industry. I think this, hopefully people become more aware of the need from industry. I think the 2-3 presentation by you from industry clearly indicated the need for collaboration between China and the UK for the common interest. I think the question there was asking, I can see this, the question asked by the audience, whether the current situation or have bring obstacles to the work. I can see from today's presentation that we have common interest, and I cannot see why that should not continue and develop further with the help of CBBC. We work now closely. Moreover, today, for example, now for the talks, so I think it's a good opportunity today for us to meet up here online, David.
Yeah, thanks, Hongming. We've sort of drifted off into another subject there, and it's maybe we'll come back to that in a moment. We've got a specific question from Kevin Rogers. What are, and I know we've already touched a little bit on this, but what are the raw materials required to manufacture these new advanced technologies, and can the panel foresee supply issues as manufacturing increases? And I know that covers a lot of material, because Jun Qiao listed a whole heap that just needed just for battery technology, and Marcus, you've touched on a heap, and so has Dr. Lee. But in broad terms, do we see this change moving forward as going to create some serious supply issues? I mean, as we've already seen during COVID with certain things.
I think if I take that to start off with, what I'm very interested in is the use of sustainable materials. Mm-hmm. So if we heat anything up, change its shape, assemble it, or use it to get from A to B, we will add carbon. Yep. Yeah. We aim as JLR, Jaguar Land Rover, to be carbon neutral in only a few years. So you're going to need to offset any carbon you add. So an area I'm very interested in is what materials could we use that sequester carbon in their production? Let's call them, biofibers. Could we make things out of trees, or lignin from trees, or flax, or any other natural products which are inherently low carbon impact of nature? Okay. Where I see as a hugely disruptive investigation could go through.
Okay, that's interesting. Anybody else got anything to add on that? This potential supply issues for these new material, the new raw materials we need for the future?
It's already happening in a way that if you look at traditionally, people use a lot of cobalt to make lithium batteries, and increasingly lithium become a supply issue, also become a much wider issue, almost similar to the old days of blood diamond situation. So you can see the industry going to start to use less and less cobalt, more and more nickel. But the problem with that is a nickel-based battery. We already look at the batteries of nickel, cobalt, manganese. The 80% is actually nickel, but nickel actually is not as stable. So that's why you actually read the news and more kind of this kind of electric vehicle on fire. And part of the reason because we actually use more nickel than cobalt. And although the industry now start even including Tesla looking at no cobalt at all, look at lithium iron phosphate, but you will not whichever way you're looking at, when you look at large quantity, when you look at automotive scale, automotive scale, the number are always scary. You look at the kind of vehicle park number projected was 2 billion units. Those are astronomical numbers. So there will be supply issues. My first job in the Energy Technology Institute, the first thing I was looking at to say, is there supply issue for lithium? I'm glad to say, I think there's enough supply of lithium, but whether the price goes down or go up is another thing. So in fact, I think there's a number of material making battery price already gone up, including this lithium iron phosphate. That's already going up as well. So yes, there will be supply issues, and there'll be something we'll be keep a very close eye on. It's a very good question, and it's challenging, but again, come by my previous comments. When the problem, people always have found the solution, deal with the problems.
I think that is it's a very relevant point, particularly about lithium. Because I know this is lithium is just one of many materials. But if we just throw in my own comments as that as well, the other issue about lithium, as you say, it's whether the supply is enough or not. It will be controlled by market forces, shall we say, the players in the market. And the other issue to consider is where is the lithium and who owns it, which is also at the moment quite a contentious issue. But anyway, the other point I sort of that occurred to me as we went through it is came across, I think in all the presentations, is that sort of, we're in a stage now where it appears that obviously there is development of entirely new vehicles, but a lot of the work that's being done on a practical level now, and as Marcus, you described it, actually into the showroom and for the sale, is about pretty much putting new materials or adapting what already exists to improve it in some way. And obviously, it's the automotive industry. When you talk about manufacturing something, it's highly traditionally highly capital intensive and takes a long time to get something from an initial design out onto in the hands of the customer. So, we're sort of looking, with the exception of a handful of companies, you would say, by the time we get to 2030, yes, there's going to be, shall we say, fully electric fleets available, but I would guess basically existing cars modified or adapted in some way. How many years is it going to be before we see the majority of new energy vehicles, or we're driving, to say, okay, those are cars or the passenger vehicles or commercial vehicles that have been designed from scratch? 2040, 2050? When will we get there? Again, open to anybody to respond on that.
Oh, it's a big question.
I know, but it's an interesting one, Marcus.
Yeah, very much. I think more than one person commented that the average in production lifespan of a vehicle is 8 years. Yeah, and then the upfront engineering is generally 4 years in advance of that. So you've got a long period of time to make disruptive you've got a short period of time, sorry, to make changes that matter. And that's, my role is to define those shoot for the moon type materials. It's not incremental. We're not after 1, 2, 3%. We're after 30% of an impact. So, and they will take many years to get into production. And that's why we need the universities doing that fundamental PhD research, the TRL 1, 2, 3, to bring it to industry and startups, to bring it through the TRL 4, 5, 6, to prove it out, to have, 4 things for me are very important. The technology readiness, and can we predict it analytically? Have you got a CAE model, computer aided engineering model that predicts it? Is the manufacturing readiness level there, the supply chain good to go, enough volume of product? Do we know the costs? And do we know the carbon impact of it? For me, there are 4 fundamental necessities before any technology goes anywhere.
Okay.
What's your question?
Anybody else? Okay. I think we're sort of approaching a lot of time. I'm just going to refer back to one question that Hongwing has already in part responded to, and the question coming from Chris is, do you think, and I say this is open to anybody on the panel, do you think the current climate in China has reduced the interest of Chinese companies to work with overseas new technologies? And I guess when the question, the current climate is talking about the current social political climate within China.
According to my opinion, I think the situation will not be that case. And Chinese companies is quite open to all the new technologies, whether they are invented or developed in Western countries or in China. As long as there are good technology and we could gain those technology through a very fair way. So I don't think it's a big problem for the companies in China. However, yeah, we are coming across some difficulties. I don't want to say who just create those difficulties, but it indeed creates some difficulty for the companies in China as well as in the Western countries. So all of us need to come together to tackle down those difficulties in order to create a very fair business environment for all of us in the worldwide.
Thank you. Dr. Junqiao, I was just about to ask you, I mean, I think it's
a bit of my company's perspective. So as I say, our R&D center been established for 11 years. So in the early days, I think it's all about value. In the early days, we, our knowledge compared with our sort of young engineers' knowledge in China, gap is huge. So we can provide a sort of immediate tangible value very quickly. And so we make the headquarters very happy by designing new family of engine transmissions in a short space of time, and they are able to, sort of do the sourcing and then do mass production. So that's very, very complementary. Clearly, those are kind of easy picking fruit. Going forward, yes, the environment changed a little bit with the COVID pandemic. We are less able to travel as before. We used to be able, I personally used to go to China at least 3-4 times a year. We used to have our engineer come here, come to the UK, doing some training. Now we all gone virtual, we not be able to travel for nearly 2 years now. So the communication not as smooth as before. But what I understand from our senior leaders, they still see as a kind of leading on the advanced technology front. That's why we are doing the cutting edge research with the UK technology developers, partly some project partly funded even by the UK government. So we are looking forward. We are looking at new technologies. So if we stand still, if we don't, if don't go forward, when we start providing great value, then I can see our headquarters perhaps now will hesitate to invest further. So it's kind of a two-way process. So as long as we provide a value, I see that investment from headquarters will still kind of kind of determined to invest in us. So but that also give us a pressure to doing new things more quickly and kind of expand our scope as well.
Thanks for that explanation. I think it's quite interesting as well in your presentation where I think you said that you had 4 research centres globally, or R&D type centres, including the UK. You also mentioned Italy specifically, which I picked up with, you said was concerned with styling. And I think it's sort of, I think those 2 examples alone just clearly demonstrate that Chang'an sees a merit that certain areas have certain expertise that it would be interesting and beneficial to collaborate with or to take part in. And I think looking at it from a different perspective, I mean, all of you companies, and Hongming, you're very international on the educational front as well, you are international businesses operating in a lot of different markets, and you have to respond in a different way. And for example, UK manufacturers selling their vehicles in China, for example, are producing models or adapting models to fit those markets. So there has to be research and development and collaboration in all areas. I think that we're running slightly over time. So I think really we've got to wrap up the session. So look, I'd like to really thank all the speakers, not just for the time that they've dedicated to the session today, but in preparing for this event, which I know is not a small thing. I think the presentations have given a really good dip, shall we say, and snapshot an insight into how you as individual companies and educational establishments are moving in the development of vehicles and specifically new materials. And I'd also like to thank again the University of Birmingham for their great support in helping us pull this event together, and Jaguar, our media partner in China, who has been live streaming this event. I got a message from Chris, who's been helping us organize this event earlier on, saying we had 10,000 people at one point on the stream in China. We will be, and of course, to thank all those people who've tuned in to listen to us today. We will be holding more events like this on the auto sector and on the broader advanced manufacturing and transport sector as we progress through the year. So please do make sure that you stay in touch with us and keep one eye on the CBBC events page. Chris, can I just ask you to just flash up the contact slide? Last but not least, as I said in my introduction, CBBC offers a range of services aimed to support companies to achieve success in doing business with or in China. And if you'd like to have a consultation about your own company and what we can do for you, then please do not hesitate to get in touch with us, either to myself directly or to my colleague, Mark Xu, who's based in China. So again, thank you to everybody, speakers and people who tuned in today, and enjoy the rest of your day. Thank you.
Thank you.
Thank you.
Bye.
Bye-bye.
Bye.
Yeah. Bye.